Uh, Good morning, students. So once again, we are going to work out chi-square model for the goodness of it. Here, there is a different problem. Let us look understand the problem. The number of scooter accidents per month, on an average, up to 10 months, the data is being given. This is true. So for 10 months, it is observed that on an average, every month, how many accidents are occurring. In the very first month, 12 accidents are reported. Second month, 8 accidents were reported. Third, 20. Fourth month, 2. Fifth month, 14. Sixth month, 10. And seventh, 15. 8, 6, 9 accidents. And in the 10th month, last month, 4 accidents were reported. So, first month, there are 12 accidents. Last month, in the 10th month, there are 4 accidents. Like that, in each and every month, accidents data was reported, and that is what it is. So the question is, are these frequencies, are these accidents per month in agreement with the belief that accident conditions were same? Accident conditions were same in the first month, second, third, fourth to up to 10th or not. So if the accident conditions are same, uh, there is no such difference between the reported accidents on monthly basis. For example, 12 in the first month, 4 in the last month. So there is a clue that if you work out this problem, what is the actually what is the assumption? What is the how you write the null hypothesis? Accident conditions are same, but 12 and 4 there is a huge error, a huge margin is there, 12 accidents and 4 accidents. So I feel I'm sure hypothesis must be rejected. That is what we must get. Okay, let us check whether, yeah, whether we apply chi-square test, what could be the result. Okay, start with aim. To apply chi-square test of goodness of fit to the given problem, that is what the aim. Method and formulae. Okay, method and formulae. So chi-square cal value can be obtained by oi minus ei whole square total divided by ei, where oi's are observed values, ei's are expected values. Okay, this is the chi-square test statistic, the formula to know the calculated value of chi-square test. Okay, how many observations are given? Almost 10 observations are given. So each month accident report is treated as one observation. Okay, start writing. Next, the next step here is, so aim is, we wrote aim and we completed stage 2 method and formulae. Now the third stage is calculation. So calculation is the third part, method and formula first part, second part, aim is the first part. Okay, on uppercase you just get a good view for right. So in calculation, we start writing. The first step here is we have to write null hypothesis, usually indicated with H naught, H naught, H0. So that is good. So what is H naught here? the accident conditions are same for the 10-month period. So that is what the null hypothesis. So we are accepting that the accident conditions are same for first month, second, third, 4, 5, 6, 7, 8, 9th, 10th month. Alternative hypothesis. H1. Okay. The accident conditions are not same for the 10-month period. Okay. This is what alternative hypothesis. And next we have to check level of significance. Assuming alpha is 5% because initially uh, by default we assume alpha is 5% in social sciences. Alpha is 5% if it is not given. So usually sometimes he will give to check at 1% level, to check at 5% level. Okay, if it is 1% or 5%, it is not a problem. You will get the tabulated value, chi-square tabulated value sheets. So of course you can carry it. But if it is not mentioned in the problem, we take alpha is 5%, even it is t test, even it is z test, even it is f test, even it is chi-square test, even it is non-parametric test. Okay, if it is not mentioned, by default assume alpha is 5%. So the next stage here is we have to compute 4, 6. Okay, month oi, ei, oi minus ei, oi minus ei square. This value, see, uh, take this value, next insert one more column, and this is so the whole divided by ei. So month number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so just write whatever that is given in the problem. All those you treat all those values as observed frequencies. So what are those values? 12, 8, 22, 14, 10, 15, 6, 9, 4. I'm just rewriting those values in OI. What are those values? 12, first observation. Next observation is 8. Next 20, 2, 14, 10, 15, 6, 9, 4. Okay. Now, what is the expected value? Second, the third column, EA. What is EA? So actually, it is not given expected value in this problem. So we take the average of the observed frequencies and treat that average as the expected frequency for each and individual item what is in the observed frequency table. So that means we take the average of the values. Just some of the values: 12 plus 8, 20, 20 plus 20, 40, 42, 56, 66, 81, 87, 96, 100. The total value of total of all the observed frequency values are 100. Okay. Okay, it is not coming. And you see, this is the total observed values and average. So 100 by total observations are 10. So average is 10. Okay. So the average of the all the observed values is 10. The sum of the values is 100. Total observations are 10. Average value is 10. So take 10 as the expected value for each individual observation. 10. Next. uh, 10, 10, 10, 10, 10. Okay. Visible. Right. OI minus EI. This is 2. This is minus 2. This is 10. This is minus 8. This is plus 4. This is 0. This is plus 5. This is minus 4. This is minus 1. This is minus 6. Next, OI minus EI square. 4 minus 2 square means 4, 100, 64, 16, 0, 25, 16, 1, 36. Okay, y minus a whole square, column number 5 minus column number 3, 4 by 10, that is 0 0.4. Next value is 0 0.4. Next value is 10. Next value is 6.4. Next value is 1.6. Next value is 0. Next value is 2.5. Next value is 1.6. Next value is 0 0.1. Next value is 3.6. Just divide the fifth column with the third column. Divide with the all numbers with respect to expected frequency. So averages, we have considered average as the expected frequency, and that too for all the observations corresponding to the observed frequencies, the expected value is 10. So here calculation is very easy, but for some problems it will be also be given the list of expected frequencies. So we computed each and the last sixth column. Now take the take the total. This is what chi-square calculated value, and that is, you add all these values, you will get sum of all these values. You will get 26.6. That is the, and that is the required value that is visible compared to rest, right? So the total value of the column number 6 is 26.6. Okay, let us finish the problem. Chi-square calculated value is equal to 26.6. Chi-square tabulated value at 5% level for how many degrees of freedom? How many observations are there in the problem? There are 10-month period, 10 observations are there. So 10 observations for 10 minus 1, that is 9 degrees of freedom. So chi-square tabulated value will be checked at n minus 1 degrees of freedom. N means total number of observations, 10 observations. 10 minus 1, because the last 10th one, it is free of choice. So it is not having any probability of selection. So we will remove it 1. So n minus 1, 10 minus 1 here, 9 degrees of freedom. The tabulated value at this level is, it is 16.919. Just make a comparison. Make a comparison. 26.9 is less than 16.919. So chi-square calculated value is less than chi-square tabulated value. Sorry, 26.9 is above than 16.919. Okay, it is greater than 16.919. 26.9 is above than 16.919. So whenever calculated value is above the tabulated value, H naught, H naught, H naught is rejected. What about H1? H1 is accepted. Thus, so what is written in alternative hypothesis? Thus, H1 is when you accept H alternative hypothesis, rewrite the statement here. The accident conditions are not same for the 10-month period. So this is what the final uh, conclusion. Okay. So proper finishing is also important. Right inference. So right inference. In inference, write down chi-square calculated value, what you got. First write here. Next chi-square tabulated value, that is 16.919. And what about H naught? The result of H naught is, it is rejected. The result of H1 is accepted. And final conclusion. It is concluded that, yes, this is what the proper finishing. So actually, you remember the four important stages in working out any problem. Start with aim, then method and formula, then start computing each and everything in the calculation part, and finally mention all the important clues and answers what you got in the problem, and finally finish with a proper conclusion. So the problem actually here is, there are accidents occurring, and on an average monthly report of accidents is given, but the observations are up to 10 months. In the first month, 12 accidents reported. Second month, 8 accidents were reported. Like that, up to 10 months, the data is given. So the problem that we want to know is whether the accident conditions are different or same. But in a null hypothesis, by usually we assume that accident conditions were same. That is what we usually take in the null as a base assumption. But we want to test whether it is true or not. Okay. Accident conditions were same. That is null hypothesis. Accident conditions were not same. That is what alternative hypothesis. But we have to check it at particular level. So by default, we assume alpha is 5%, and we computed the chi-square table with respect to months, uh, observed frequencies, expected frequencies, and OY minus EI, Y minus EI square, Y minus E square by EI. But here, all the observed frequencies are is already given, but we have to take the average of it, so that expected value for each and individual item will be we will get it. So by taking average, the average is 10. So we take 10 for as an expected frequency for individual corresponding observed items. We completed the table, and finally we got chi-square calculated, that is 26.6. How many observations are given? 10 observations. So n minus 1. 10 minus 1 means for 9 degrees of freedom at 5% level, we check the tabulated value, and that is 16.919. So calculated value is slightly above than the tabulated value. Obviously, we reject null hypothesis and accept alternative hypothesis. This is one of the simple chi-square model of test and goodness of fit. Okay. But remember to follow the four important stages. Start, right, mention with aim, method and formula, calculation, inference. Make it a habit. Okay.